Hello children. The light, it always travels in a straight path. But when it falls on a plane mirror, it reflects back. But what will happen if it moves from one transparent medium to the another? Let's start with an activity. For this activity, you need to take one bowl and then put one coin in it. Now just move backward until you are not able to see the coin. Pour water gently into the bowl. What did you observe? The coin which was not visible from this position, after pouring water, it became visible. Let's talk about the science behind it. Refraction. Refraction, it is the change in the direction of light when it passes from one medium to another medium obliquely. So whenever the light ray, it falls on any opaque object, it bounces back. But when it moves from one transparent medium to the another medium, then there is a change in the path of the light ray. But because the medium it changes, the process it is known as refraction. So here is a word obliquely. Obliquely means that the light ray, it is incident on any other transparent medium like glass slab at a particular angle. The light ray, it is neither perpendicular to the glass slab surface nor it is parallel, but it is incident at a particular angle. Cause of refraction. Speed of light is different in different media. Media means medium or the substance in which the light it is traveling. Speed of the light in the air is 3 into 10 power 8 meter per second. Speed of the light in the glass is 2 into 10 power 8 meter per second. As it is very much clear from this numeric data that the light it will move fastly in air. Therefore, air is optically rarer medium, whereas the glass it is optically denser medium. We can also define optically rarer medium as the medium in which the speed of the light is more. We can define optically denser medium as a medium in which the speed of the light is less. What will happen if the light ray it moves from optically rarer medium to the denser medium or from optically denser medium to the rarer medium? Let's see. Case 1. Refraction of the light when it goes from rarer to the denser medium. Here, incident light ray AO, it enters the glass slab. It is incident on the glass slab at the point O. There is a change in the path of the light ray when it enters the glass slab. And the refracted light ray, it moves towards the normal. As you can see that the angle of the incidence, it is not equal to the angle of refraction, but it is larger than the angle of refraction. This is because the refracted light ray, it moves towards the normal. So, when the light ray moves from the rarer to the denser medium, the refracted light ray will move towards the normal. Case 2. Refraction of the light when it goes from denser to the rarer medium. Here, AO is the light ray which is incident on the phase DC of the rectangular glass slab. When this light ray it emerges out from the glass slab, the emergent ray it moves away from the normal. As you can see, the angle of the incidence it is not equal to the angle of refraction, but angle of the refraction it is larger than the angle of incidence. We have just studied the refraction of the light from the air into the glass or from the glass to the air. But now we will discuss both the type of the refraction in the same diagram. This light ray it is incident on the glass slab. It was originally moving in the air, which is an optically rarer medium. When this light ray it enters the glass slab, it bends towards the normal. A second time refraction takes place when this light ray it emerges out. But because the light ray it is moving from the denser medium to the rarer medium, the emergent light ray moves away from the normal. Now as you can see that the light it is refracted 2 times here. If we extend this incident light ray forward, this is the original path of the incident light ray, then we will observe that these 2 lines they are parallel to each other. The perpendicular distance is known as lateral displacement. The lateral displacement it is directly proportional to the angle of the incidence, directly proportional to the refractive index of the glass, and directly proportional to the thickness of the glass slab. In all our discussions so far, we have assumed that the incident ray of light falls obliquely on the surface of the glass slab and bending of the ray of the light takes place. But what will happen if the light ray it is incident at 90-degree angle? Here, the angle of the refraction and the angle of the incidence is 0. If the light ray it is incident at 90-degree angle, the light ray it will move undeviated. There will be no change in the path of the light ray. No refraction takes place. Laws of refraction. First law of refraction. The incident ray, the refracted ray, and the normal at the point of incidence all lie in the same plane, which is the plane of the paper. The second law of refraction. It gives a relationship between the angle of the incidence and the angle of refraction. This relationship was discovered by Snell experimentally in 1621. So the second law of refraction it is also known as Snell's law. According to Snell's law of refraction of light, the ratio of sine of the angle of the incidence to the sine of the angle of the refraction is constant for a given pair of media. Mathematically, we can write it as sine I by sine R equal to constant. Since the refractive index is the ratio of 2 similar quantities, it has no unit. It is a pure number. The constant it is known as refractive index. Light is refracted in going from one medium to another because its speed changes. Due to this, The refractive index, it can also be written as the ratio of speed of the light in the two media. If the light ray, it is moving from vacuum or air to another medium, then the refractive index is called absolute refractive index. It is denoted by N, and the medium other than the air or the vacuum, it is written at the subscript. If the light ray, it is moving from one transparent medium to the another, and none of the transparent medium is air or the vacuum, then the refractive index is known as relative refractive index. So the refractive index of the second medium with respect to the first medium is equal to speed of the light in the medium 1 upon speed of the light in the medium 2. Refractive index, it is the specific property of any substance. So it can be used to identify it. Air, it is having a refractive index 1.0003. Diamond, it is having the refractive index 2.42. We can also say that higher is the value of the refractive index, the denser is the medium. And if the medium is optically denser, the speed of the light ray will be less. So we have learnt about refraction in this video. Here is an assignment based on the topic we have discussed.